Hey everybody, my name's Tom from Moto-Resto LLC, Bradenton, Florida. Today we're going to get into some motorcycle charging system diagnostics. So let's get right to it. On Moto-Resto TV. Hey, that isn't a thing. I checked. Hey everybody, welcome back. As I said in the brief intro, this video is going to be on diagnosing charging systems in motorsports. And I say motorsports because this doesn't just apply to motorcycles. It can be used for ATVs, I don't know, maybe even snowmobiles, things like that. But I'm going to essentially be using components off motorcycles to give you baseline or basics on what you need to do to properly diagnose a charging system problem. All right, so what we're going to need in this video, of course, and for your actual diagnostics is, your subject, your patient, and you're also going to need some test equipment. Now, I have two types here sitting here, or two brands, and both with different capabilities. This is a cheapo Klein Tools job, which for 98% of any diagnostics you do on motorcycles, any diagnostics, this is just fine. Put it in an auto range and let it eat. But in certain applications for charging systems, you're going to need a better meter. This is a Fluke 289 True RMS multimeter. This is like a $500 and something meter because in certain charging systems, the resistance is so low that you cannot accurately get a reading with a cheapo meter. It's out of the range of the meter, so you really need a meter that's a lot more finite and a lot more accurate for that. But we'll get into that here in a little bit. Let's go over the basic types we're going to be looking at today. This guy on the left is essentially an alternator. This is a complete alternator that is on some motorcycles that's driven off of a chain or I guess some are gear driven, I don't know, mounted usually on the top of an engine and into a part of the actual crankcase that accepts this as an O-ring to seal it off, and this merges, or this articulates with the drive portion, and this of course is the driven portion. Now the difference between that and a separate rotor stator setup, which is what these guys are off of, is this simply is all enclosed. I'm going to get into this one in a little bit more detail later because I have to explain how this works, and then when you know that, it's a lot easier to diagnose a problem. So I'm just going over the types we're going to cover in this video right now. These two are your typical stators from a rotor stator setup. This is a typical rotor. This is not for any of these. This is actually a spare Magna rotor, Magna VF750 rotor. It has permanent magnets that are put in there in a certain series as far as their polarity. And this is the spinny part, goes in the crankshaft, and it spins around a stator. On certain motorcycles, like some of the old Hondas, the early CB750s, I'm not really sure about any others that had it, they have a field coil type of a rotor. I can't really get into that in great depth in this video without having one in front of me. I'm going to reference it because a field coil type of a charging system, even though it has a rotor and a stator, is actually very similar to how this produces and regulates electricity. B plus 12 volts for a motorcycle charging system is very similar in the way it does it, and I'll explain it again when I get into this. All right, first things first, let me introduce you to a typical KZ1000 motorcycle stator. This is exactly what this is from, or for, it applies to. This is from Rick's Regulator and Rectifier up New Hampshire. This is one I keep on the shelf for the KZ1000s. It is brand new, reconditioned by them, and so I know it's good. In fact, all three of these examples that I'm going to show you today are known good. They are good, and I don't want to necessarily show you a bad one because, it's once you have to be able to understand how to test and determine it's good before you can even determine whether it's bad, because obviously you're not going to know it's bad unless you know what's good. So we're going to start with this one first. But first, we're going to do is talk about the basics and trying to root out the problems in the charging system by simply looking at the wiring. These are notorious. I don't care what motorcycle it is. These plugs are notorious for getting a little corroded over the years. Corrosion equals resistance. And when you get resistance, current has difficult time passing. And when current has difficult time passing, it generates heat. Hondas are particularly known for this. This is the plug end of a voltage regulator from my Magna, for example, typical one. And these plugs can get screwed up, whether it's on the output side where you get the actual DC voltage coming out in amperage, or on the input side, which is where the AC comes in. We're going to cover that here in a second. These can get corroded, and what they can do is, again, throw some resistance into the circuit. It melts these plugs, and it just compounds and gets worse and worse, and it just fails. So always check your wiring first. If you don't know exactly where it is, pretty simple. On most of these motorcycles, if you have a rotor stator type, it's generally on the left side of the crankshaft. So you find where these wires penetrate out that side of the motorcycle, the crankcase. In this case, it would be a cover, and then you just follow them up. And you might have to take a couple body panels off, but you'll be able to follow up where these wires go, and they're going to go up to a plug that goes into some sort of a regulator. Again, this is a little different. We're going to cover that again later, but as far as the stator rotor type, you just follow the wires up and it'll go into a regulator rectifier. Generally speaking, these are yellow wires. Of course, in this one they are not, and on this one over here, which we're going to cover too, is a Concourse 14 stator, and it's known good. I know it's good. That is not yellow either, so don't be fooled if you don't see yellow wires. What you're going to see, however, in a more modern and certainly larger displacement motorcycle, are 3 of them. There are 3 wires that are going to come off of the actual stator itself that are going to be providing alternating current. They provide alternating current. This particular KZ wiring harness just simply shares 2 other wires. I think one is for the neutral light, and the other one's for, I forgot what, but I don't remember what it's for. It tells you when you're in neutral, and I think the other one may be for kickstand. It just simply shares those wiring because it's in the same general area of the bike. But if you just take those out of the loop, you have 3 wires from a 3-phase, basically an alternator at this point. It generates 3-phase AC. Now, what do we mean by that? There's a good diagram in the KZ1000 service manual that kind of explains that. They call it a dynamo. Dynamo! It sounds like a laundry detergent. This is your waveform, if you had it on an oscilloscope, of your AC pulses. This is ABC for the 3 phases, and so that's what it generates. It generates 3-phase alternating current. Now, yes, on some 6-volt systems, like on the tiny Hondas and things like that, you may only find 2, like it has a 2-phase. Either way, the diagnostics are the same. I'm only mentioning the AC output side is because there is a way to test for that outside of testing for battery plus DC, which we'll get into here as we go along when we test these things. So again, number one, first thing we want to do is check wiring. We want to check for plugs. We want to check for corrosion. We want to check for wires that are chafed, anything that might be shorted to ground, anything that'd be causing us the problem. All right. If you don't find any of those, then the next thing you need to do, and the thing that I do first, is I want to check for how good the stator itself is in regards to what the service manual says the values are supposed to be between the 3 phases. And what we do is we take a digital multimeter and again put it in auto range, and what we're going to test is between the 3 phases. Even if there are other wires on a plug like this, the only thing we're interested in is the 3 phases, whether they're 3 black wires, 3 yellow wires, or what have you, and we're going to test between them. We're also going to test between each one of those and the body of the stator because we want to see if it's shorted to ground. So those are the 2 main tests we're going to do with a digital multimeter in resistance mode on a stator like this. Any stator you can do that. So look up your information, your service manual. If you don't have a service manual, we'll go over that here in a second. But basically, a rule of thumb on a older motorcycle, Japanese motorcycle stator rotor charging system is you would like to see 1 ohm or less, approximately an ohm or less, on each of the phases between each other. None that are significantly greater, or a dead short, of course, would be pretty telling, than the other. And of course, no shorts to ground. So what we're going to do right now is we're going to do a test on this one with a meter, and I'll show you what I mean. Alright, so I have my Klein meter hooked up here, and again, you can use any, even a cheapo meter is fine for this kind of thing. The only time you wouldn't be able to use one is when you look in the service manual and it has very, very low resistance readings. This is what we're going to need for the Concourse 14 one. I'll explain that here in a second. But basically, what you do is you simply unplug the stator from the main harness. Make sure you're testing the stator side of the wiring, so where it goes down to the stator. And we're just going to grab each of these, and I think I'm just going to back probe them instead of put them on the plug. It's a little easier to show you. That way you can see it this way. And what we're going to do is you just rotate it around. So you start at any one and go to any another, or the other one I should say. And this is showing 0.5, 0.4 ohms. Now we're going to go to another one with that first one still in the same place, 0.5 or 0.4. Then we're going to bring this one back and go over here and 0.4, 0.3. All right, so we're right in the range. That would test out good. So remember, there's only 3 wire. You can start at any one, and usually I go a couple of different rotations, starting at one and finishing with another, and then reverse it around. So you do it 3 ways if you want. So we started over here before. Now we'll start over here. We'll hit this one, see what we got. Same thing. Then we're going to go crosswise over to there. Same thing. And then we'll start on this middle one. We're just going to rotate it around. You're really just duplicating the test, but it's good to do it this way because sometimes you have bad connection at the actual terminal, and you just want to verify, because if you just go off of one set of readings, you might say, well, this thing's showing very high resistance in one of the legs, and when it really doesn't. All right, so we got about a half an ohm, 0.5. Service manual says, what does the service manual say? Service manual says about 0.5, it's actually 0.56 to 0.84. But again, this meter is a little bit off, most likely. It's not the most accurate tool in the shed when it comes to meters. So I would call this good. And also we look for the fact that they're all about the same. So if we did one of those rotations, or even the first one, and we started off with one and went to one, another one, and it was good, then we went to the third one and it showed like 1.2 or 1.4, we would say there's a problem, like there's a problem internal in this particular stator. Or if it showed OL, for out of limit, out of limits like this, it would be an open. Now, speaking of opens, that's obviously bad, but we want to check for shorts too, and I mentioned that before. Polarity or orientation of your leads means nothing in any of these tests actually, and it doesn't mean anything in here either. So you want to pick up each leg one at a time. Actually, let's start over here so we kind of keep a rotation even. And we just go to the body of the stator. If the stator is mounted on a motorcycle, just go to a good ground. What we don't want to see is we don't want to see any reading. We want an open circuit here. This verifies that we do not have any of these phases, if you will, shorted to ground. So that's 1, that's good, nothing. 2, that's good, nothing. And the third one is good. You don't need to rotate these around unless you just want to reproduce it because you weren't sure about, how good your contact with your terminal leads, your leads were to whatever you were testing. That happens a lot because, the outside of these motorcycle cases, like a case bolt or something, is a little bit corroded. So you just want to make sure you got a really good ground. So these are really the only 2 tests that you can do and that you really need to do on resistance with a stator. The third test is you want to see what the AC output is. Now on these kind of setups with a stator rotor, it's really easy to do that. On this guy here, it's a little more difficult, but we'll get into that again later when we cover this separately. So what you do with that is, if you still do not have good charging of DC voltage, before you completely, call basically call a red flag on your regular rectifier. You want to absolutely make sure that you are generating the appropriate amount of AC voltage out of your stator. Okay, and how we do that is actually pretty simple as well. You leave the, of course this has to be mounted on the motorcycle. It has to be all intact before you remove the stator or the rotor. So again, you're just diagnosing things by unplugging the actual stator side of the wires from any plugs, so they're not connected to the motorcycle wiring, the actual electrical system at all. And we're gonna be very careful about this. We don't want to short anything. But what we're gonna end up doing is we're gonna end up testing AC output on all three of those phases, like we check for resistance. And so all you got to do is really just put your meter over to AC. Now, naturally, I can't simulate that, but on a meter like this that only has symbols, you just look for the little squiggly signs, so volts and AC, and it also has DC as a option there too. So make sure that you set the right range. So right now when we put over, it actually defaults right to auto and AC. You see the little squiggly line right there. So now we're in AC auto. That's fine. And you're gonna essentially set up where you start the motorcycle and you go between the three phases like you did when you check for resistance. And you look at your service data, it usually has a certain amount of AC voltage at a certain RPM. So like, 80 volts or 68 volts or 90 volts at 4,000 RPM, whatever it is. Remember, that's AC, alternating current. And you just go between the three phases and look for that output. If you have the appropriate output and nothing is too low or too high on either one or all three when you test them and go around in your rotation, then you can absolutely call the stator good. Now on an old stator, even if you have decent readings on your resistance test, sometimes you hook it up and do an alternator output test, which is really what this is as far as AC goes, and you'll have marginal AC output. And that probably means that your stator is marginal. So if you have a low charging situation where you actually are charging the battery, the rectifier and regulator are working properly, or you can assume they're working properly. We're going to get into that too here briefly. But it may be marginal, all right? So you just have to consider that. Sometimes, when you get into a situation, you could chase your tail around and realize, you know what, it's just cheaper and easier for me to replace the stator. Go ahead and do that if that's, within your capabilities and your budget, because new is always better when it comes to this stuff, especially when you get it from like Rick's Regulator Rectifier up in New Hampshire. They have excellent products. They're not a sponsor. I'm no way affiliated with them, but I exclusively use their products for charging system repairs on motorcycles, ATVs, the whole bit. So again, that's your basics on checking a stator as far as whether or not it tests good. If it tests good on, again, whether it's got good resistance between the phases, it's got no shorts to ground between the phases, and you've got good AC output between the phases, then you can call that stator good. If it's marginal, then you can call it marginal, but you're at least getting some output from it. Maybe you can limp it down the road a couple of more years or something. Right now we're going to go ahead and put the Concourse 14 one up in here, and the reason why I'm showing this one is because the tests are identical, but the readings are a little bit more difficult to achieve on a meter like this. For this, I'm going to go ahead and put my homemade alligator clip gizmos on here. We're going to do the same test. We're going to go back to resistance, make sure it's in auto, which it is. Oh, no, it's not. Let's go to auto. Here we go. We'll go to auto. Can you see that okay? Yeah, I want to make sure there's no glare. And we're going to do the same thing. Make sure you're not touching the terminals with your hands like when you're doing this. Like, you don't want to do something like this because you're going to throw the resistance off. Your body will skew the resistance of that, so you want to make sure of that. And of course, when you're working around anything that generates electricity, AC, DC, otherwise, take appropriate precautions so you don't get zapped, especially for somebody like me that's got a pacemaker. Oh, my heart. Just kidding. So what we're going to do is we're going to hook up to two of the phases again, and we're going to start our rotation test. Okay, so this says 0.2, 0.1. So you're like, oh, that doesn't look bad. And we go over here, and 0.2, 0.1, and so on and so forth. I can tell you right now they're all going to come about the same. All right, but here's the problem. There's always a problem. There's always a catch. The service manual values for that is actually 0.05 to 0.5 ohms. So again, that's 0.05 to 0.5 ohms. So the high side of what this is supposed to be at is at 1/2 of an ohm. So again, this meter is just not accurate enough to read that low of a resistance, all right? Because again, it's 0.05 to 0.5. Now, yeah, we can do this. Should read 0.5, but you know, these things are just really crappy below about, you know, maybe about 0.5, 0.8 ohms. You know, they're just not very accurate. Like right now, look what it's reading. It's reading 0. We have it in auto and ohms, and I'm going between two of the legs that I just checked before, but I kind of let the meter settle out. And you'd say to yourself, oh, I got this thing is like dead shorted or something between the legs, so this stator is no good. And that's not the case. I know the stator is good. So when you get into a really low reading like that in the service manuals, you got to have a meter that can read that. We're going to go ahead and fire up the fluke and test this again. Fire up the fluke, and it's something you don't get to say in a sentence very often. So we're going to do with the fluke here is we're going to be using the you know, the actual alligator clips, not alligator shoes, but clips that come with the actual terminals from the fluke, and these are much higher quality. These leads around, not terminals. So what we're going to do is we're going to fire up the fluke. There, I did it again, and what we're going to do is let her boot up. She's going to boot like a little computer. And we're already in ohms mode, and right now it would be like an auto ranging, but that's, see, it says right there auto ranging, but that's not really going to be good enough when we're measuring or metering a very low resistance. So I want to put the leads together, and this meter has an interesting little feature where if you hit menu, you can go into relative, and I selected it already, and then you hit REL again. And what it does is, you see the reference, this thing would have like 0.12 ohms resistance in the leads if we did not zero it out. So we're essentially eliminating that resistance from the leads. So it's going to calculate out and go, okay, well, I'm going to take I'm going to factor in the resistance of the leads, and then you get a much more accurate reading. So now we're going to go ahead and hook up to each of our two of our phases at least. Try to keep your leads stable so they're not going to go, you know, catawampus on you. And again, we want 0.05 to 0.5. So we're at 0.10. We're right basically almost in the middle of that. So, or 0.09, that's fine. So this, you can see it's, the other one, yeah, will read that low, but you can see it migrated to 0 because it just can't read that low finitely, or the finite amount of tolerances on these cheapo meters. That's where you need a meter like this to verify it. So whenever I see a service manual that's got a reading like that, some of the newer Hondas, dirt bikes, things like that will have that. I got to pull the fluke and fire the fluke up. I said it again, and then we can get a much more accurate reading of the stator. So I already know this one's good. I'm not going to go through all three of the phases again and go a couple of rotations, but that just shows you that sometimes you need some more sophisticated measuring equipment to actually get an accurate measurement of a charging system component. Here's what it looks like when I just have it in auto ranging on the fluke and I just don't set it up for relative. It's showing 0.20, which technically is basically good because again it's 0.05 to 0.5. But let's say that this stator was sitting a little bit on the high side and this is showing 0.6 or 0.7. You might say, well, this is scrap. Maybe it's not, and that's why we need to put it in the relative mode, because we get a much more accurate reading. We take the you know, the actual resistance of the leads out of the equation, and again, it's just more accurate. But I just wanted to give you a comparison of what it looks like when you don't do that. This meter is much better. These types of meters with higher accuracy are much more appropriate for measuring any stator that's got, you know, anything under about an ohm resistance. You get to 0.6, 0.5, and they're just really not that accurate at that low amount of, you know, that low resistance. So you definitely want a meter that's a lot better for that, like a fluke. All right, so again, let's refresh. On these stator rotor types, like up here, oh, you can't see my hand, can you? These stator rotor types, like up here, and there's your rotor over there behind the fluke. You see again that we check for resistance between the phases. We check whether the phases are grounded out. And if that's not the case and everything else is good, then you might have a problem with the magnets in your rotor. That's mentioned, for example, in the dynamo chapter on a KZ1000. I've never seen that before, where you'd have to change a rotor out. If you had broken magnets or something, which would probably tear everything up in there, then yes. Sometimes what will happen is when these are installed, especially if somebody replaces one, the fasteners that these go through, sometimes, most of the time they'll mount to the inside of the cover that goes, and the rotors are sticking out. The open side is out. So the rotor will be, not all the time, but the rotor will be, open like this. And then the stator will slip into it. So the stator is actually mounted in the cover of that side of the bike. So what will happen sometimes is guys will put the fasteners in, which are like cap bolts. And you really need to Loctite these in, at least with blue Loctite, and torque them up to the proper spec. But if they don't and they loosen up, this thing starts warbling around and actually starts contacting the rotor, and you can see bad things can happen when that occurs. So if you see some carnage in there, that's probably what happened. So again, unless there's physical damage, it's pretty obvious. We need to test these things with good known equipment, and then determine whether or not we have proper resistance between the phases, a ground, dead short, or an open. All right, that's pretty much all that's going to happen to that. If that tests out all good, we're going to move to the other part of the charging system, which is the regulator rectifier. Now, I'm going to do that separately as far as what they typically use for, the stator rotor type. But the reason why I'm kind of going into this is because this is an integral stator, rotor, and regulator rectifier all in one. And to top it off, it's really a field rotor. It's not a permanent magnet rotor. What I mean by that is it's an electromagnet rotor. So what happens with this, and a lot of the more modern bikes are like this, that have these separate alternators that stick, again, as I described before, they're mounted usually to the outside of the engine casing and then driven from the inside through a feature in the casting to where they bolt up. You see it only has 2 wires. So how in the hell can this work if it's only got 2 wires? Well, it's actually pretty easy how this thing works. How these work are, and in this particular case, what you have is you have the diodes, the diode pack for the actual conversion of AC into DC, which we're going to cover a little bit more when we get into the separate one, right here. And you can see we've got 3 phases right there. So there are 3 phases to this stator. There is a stator in here. And of course, you have a rotor that spins within it. But again, it's an electromagnet type of a field rotor, or a field coil, really is what it is. So what this does is when this thing is spinning and it's generating power, there's essentially power that goes out and then power that comes right back in. Whatever ground it gets through the body, whatever ground it needs, if any. And what this guy over here does is a transistor of some sort that actually sees the voltage that's coming back in. If the voltage is low that's coming back in, it will essentially increase the amount of DC that is going to that field coil. So therefore the electromagnet gets stronger, and as the electromagnet gets stronger, it generates more alternating current. And when it generates more alternating current, then of course it gets rectified here and it gets regulated here, and it just keeps kind of self-monitoring itself. It's kind of crude because this is from a 1989 ZX10. This is the same one that works on a Concours 1000 and probably a bunch of other types of motorcycles. But that's basically how this works. So to diagnose this one, technically, according to the service manual, you're supposed to desolder these 3 stator wires from this regular rectifier in order to isolate it and to determine whether the stator coil is bad or not. I have tested these, though, with the thing connected, and I've gotten valid readings by doing that. So let's go ahead and turn this on, and we got it in ohms auto. And we're going to do that right now. We're going to kind of test it. Let me take the leads, the alligator clips back off. And we're going to go between each one like we did before. Wrong mode. Silly me. Can you see the meter? Probably not. Doesn't matter. I'll tell you what it says. That's coming up 0.4, 0.3, 0.4. That one's about 0.5, 0.4. Okay, so they're all coming up about 0.4, 0.5 ohms. If you looked in the service manual, you'd find that that is the correct reading for the stator coil in a charging system setup like this, which is essentially, again, an alternator. So I don't really know why they say that, because of the diodes that are in there. I was thinking that this would probably be isolated from everything else anyway. But I just test them that way when it's connected up, and if I get a good reading, at least it's something relative that I can kind of sort of hang my hat on and determine that the stator coil is good. The rest of it is almost impossible to test because you need a special test rig I read in the service manual to test like this transistor and actually test the actual, this is the rectifier over here with the diode pack in there to rectify AC to DC. But it's actually a very simple, but it can throw you off, complicated a little bit in your mind, maybe. In my mind it was, setup with just 2 wires. Here's where the funny business comes. The reason why I have this sitting here is because on my 89ZX10 that I sold to actually one of my customers, I had a high charging output situation. This thing was belting out like 15.5, 15.8 volts DC at the battery, which is absolutely too high. 14.6, 14.8, I'd be turning handsprings. But this thing was really cranking it out. And I'm trying to figure out why it's doing that. So I ended up just replacing. I just got another one off of Fleabay and put it on there. Did the same thing. It's cranking out DC volts. So I'm like, well, maybe the regulator's bad in there or the rectifier's bad. Nope. And then of course the stator coil is all tested right. Here's the problem. If you have a bad connection, what's going to happen is the voltage coming back, the DC coming back, is going to be read as lower than it actually is, because if you have a bad connection. And this thing is going to say, oh, I don't have the voltage I need to up the amount that's going to the field coil, you know, the actual field, the electromagnet in here, and it's going to crank out more power. More power! And then when that happens, it's going to start overcharging. I found it out because on that particular bike, the plug that these wires live in, that comes off of actually up by the main plug by the steering head, I didn't see it at first and it was corroded, and once I fixed that, boom, the thing started charging fine. So these can kind of throw you off a little bit because they're integrated. There's only a limited amount of testing you can do. I don't know if you can actually run this thing and test the AC voltage off of each one of these. I imagine you could, but in this particular case, if you have one of these, and especially if it's overcharging, triple, quadruple check all the connections. Replace connectors if necessary. You know, repin them out, clean them, do whatever you need to do. Follow the entire circuit. And I bet you're going to find a situation like that. If it's charging low, most likely a bad voltage regulator, you know, in this case, whatever this is, a transistor or something, right? And you know, of course, this is your brush pack that puts the voltage into that rotor, because remember the rotor is the spinny part. You see it spinning? So it's putting that voltage into that electromagnet. So there's could be a problem there too. You could have worn brushes. These are really easy to pop out and get a look at, you know, by just following the service manual. They have instructions on how to do that, because I did that. Sometimes what you can do is take these brushes out, clean the commutator on this rotor, and put them back in if the brushes are okay, and it'll work fine. So yeah, I just wanted to kind of give you a basic on these types that are put together, because they are completely different, but then again, they're very similar to the stator rotor type of a charging system. Let's talk a little bit about voltage regulators, ones that are separate from the ones that I just showed you, like a typical rotor and a stator type of charging system, like on KZ1000, my Concourse 14, a lot of modern bikes, ATVs, things like that. If it's got a separate voltage regulator, then it could certainly be part of the problem. I can say with great confidence that the majority of charging system problems that I have come across in my experience here working for myself on customers' machines have been about 75% stator and the remainder are regular rectifiers. Usually these things are pretty much bomb-proof, but I did a DRZ 400 that tested out with a good stator, and it was a voltage regulator that took a shit, and I've done other motorcycles that have the same similar circumstances. We did all those tests like I showed you. This test's good, the AC output test is good, so now we have to move up the line. Again, we check all of our connectors. It's really, really important to check your connections. On this particular setup is off the Magna, the VF750C 1982, which again is a typical charging system, even as far as the layout is, even in a more modern machine, where you have your 3 separate phase wires, which are yellow in this case, off of the stator. This is of course a regulator side, so the stator comes in here. This side goes into the actual part of the bike and provides ground and battery. It connects to the battery, so this thing can actually charge the battery. This wire in this particular one, not all of them have this, but this black wire in this one, in case you have a setup like this, is actually a sense wire that tells this thing what the battery is at, so it can control the amount of voltage that's going to the battery. Not all of them have that. A lot of them are integrated that way. And the only reason why you see 2 of each of the same color on this particular one, don't let that throw you off as well, is because manufacturers simply chose to run 2 wires instead of just one fat one, which are sometimes kind of harder to do, and they would need a different plug too. And it carries the same amount of current because these are essentially the same circuit. So they just chose to do it this way. They needed more than one, but they didn't want to put a bigger gauge wire. So that's the only reason why you see that. Tests on a voltage regulator of this sort are extremely limited to only one thing, and that's the diodes. The only thing you can test is the diodes. This is all potted, with the exception of like an early CB750, other bikes that use a mechanical voltage regulator, and even messing with those is not recommended per the service manual because they're factory set. In that case, the best thing to do is, if you suspect it, is simply replace it. But again, you can check the diodes. If the diode pack or the bridge rectifier of the diodes part of that rectifier rather, are bad at all, then yeah, it's not going to rectify the AC into DC, and you're going to have a low or no output DC in your charging system, even though the AC output getting into it is fine. How we do that's actually pretty simple on this. What we need to do is we need to select a diode mode in a meter, which usually has a little symbol. You see that little diode symbol there? It's in this particular one. It's in the same setting as your beep beep when you want to check continuity, and also ohms. So we're going to hit select and go to diode. You see the diode come up in the screen there if there isn't any glare. We want it in diode mode. What we're going to do here is we're going to check essentially like a go no go. So polarity matters in this one, whether or not that the diodes are doing what they're supposed to do. Essentially in diode mode, we're certainly going to get a reading, and the reading we get in diode mode is actually generated by the meter. The meter is generating I think it's like a half volt DC or so, and it's sending that through the diode so it can actually check it. There has to be some sort of a voltage going through, and then one way it goes through and the other way it doesn't. That's how these diodes essentially, I think it's like they essentially chop the AC sine wave down to DC, and that's how it's generating the direct current instead of alternating current getting your battery. So what we're going to do is we're going to select, I think I'll start here. We're going to select one of the phases on the actual alternator side, and then we're going to go to the ground, which is in this case the green wire on our plug here, and we're going to go ahead and touch that, and we're going to see if we get a reading. If we don't get a reading, it doesn't mean much. We're going to go this way. Actually, I can use the regular terminal leads on this and then go back. Okay. Now you see we got about 0.5 volts going in that direction, but we had nothing in the other direction. That would be a pass on that particular phase. So keep track of which one you're testing. And of course you're going to need to go back and forth depending on which direction that you're in. I don't really remember the direction of how these work as far as the colors of your leads. So try it one way, try it the other way. If you get it one way and you don't get it the other way, then that is a good diode inside of your rectifier. And again, you got about 0.5 volts. So This the only thing you can check on a regular rectifier of this sort is the diodes. The only other way to check the actual output is to utilize a known good battery, a known good alternator side, in other words your stator rotor, and a known good regular rectifier. So really what you need to do is you need to buy a new regular rectifier. And you're probably going to do that anyway if everything else checks out. But if you wanted to make sure absolutely that it's that particular component, again, known good battery. You got to have a good known 12 volt, which rests at about 12.96 volts DC when it's fully charged. Something that ain't ready to shit to bed, like a new battery, for example. Good connections, a known good charging system down at the bottom end, which of course is this again, or the other one I showed you. And then if you still are not charging right, it's going to be your regular rectifier. Yeah, you can check the diodes all you want till the cows come home, but most likely it's in the voltage regulation side of this integrated circuit, and it's just going to be basically scrap. Again, the way you have to do that is when everything else is known good, you simply throw in a known good voltage regulator, which, if you went to buy one, again, I would recommend from Rick's Regular Rectifier, or Rick's Motorsports Electrics, as he's also known. Buy yourself a new one that's appropriate for your unit. If you're going to get a lithium battery, he has options for that. And then you get the correct one, plug it in, and check it, and then all of a sudden you got charging. There you go. You just diagnosed your voltage regulator rectifier, especially if you've already done the diode check. All right, so let's do a quick summary. I have the two types, main ones that I've discussed already. I have this self-contained alternator style. This is very similar to like an automobile alternator in many respects, but not the same. And you're going to have your old school type of stator rotor type. We check on this one, of course, we want to check to make sure that the resistance between the phases is good. Nothing is shorted to ground. There's no opens. I cannot overemphasize checking all the plugs, checking all the connectors. And if they look even slightly corroded and you're like, oh, that's okay because there are other connectors on this bike that look the same and that circuit works fine, it doesn't work that way. You want to make sure these are 100% good connections. Repin it out. I have an electrical kit from a place called electricalconnections.com with all vintage plugs and different pins and the appropriate crimper. And what I'll do is I'll just shotgun a plug like this. This is probably one of them that I did, and just put new terminals in it and be done with it. Because again, if you have any resistance in this thing, it's going to follow you up. Any significant resistance will result essentially in a charging system failure. You're not going to melt this in most cases unless it's a dead short, but of course, look for physical damage. If you have to take the cover off and pull the stator out, I explained before that sometimes the stators can come loose from the cover. This guy is a little bit more complicated. Now, again, the newer bikes may be completely different. I don't know if they're brushless or whatever, but I'm really talking more about the old school stuff that uses a alternator or a charging system like this. But even some of the older, like I said before, CB750s, had the same type of field coil rotor, and that voltage regulator would essentially pulse it. I don't know what the refresh rate was or anything, but it would pulse that on and off, and it would generate and of course the battery smooths everything out. The battery is the great equalizer. Battery's a big capacitor. Capacitors are used to smooth electrical pulses and circuits, same thing. And so that works out pretty well where you don't have your lights all flickering all over the place. All right, hey, thanks for watching. I appreciate it. I hope you got something out of it. I hope you learned something. These are charging systems on motorcycles. They can be a little foreign to perhaps newbies and newer technicians, newer people that are diagnosing an old bike that they bought in particular. They're really not that complicated. I can't overemphasize, get your service data and read through it. A lot of times the service manual will give you an entire explanation of how the charging system works. They'll give you a good fundamental knowledge on, well, okay, it works that way, so that's why I'm testing it this way. You'll better understand essentially the diagnostic side of it when they go through it step by step. That's really important. The other thing, again, I can't overemphasize this. Check all those wires, check the plugs, and I failed to mention during the actual content that you got to check grounds especially. Grounds will really throw you for a loop and will give you a problem if you just have a bad ground, especially something that's hidden, difficult to find. You get a bad ground, throws the whole thing off because, of course, the system needs to see a ground as well. So anyway, speaking of grounds, I hope we're all grounded into this now and we understand how to test a motorcycle charging system a little bit better. It isn't that hard, even with a simple meter. Some require a little bit more sophisticated meters, but we already covered that. So let's move on and say thanks for watching. We'll catch you on the next video.